Okay, so let's take a look. Here we have log problem 1. Between z is 0 and z is negative 2.14. So first thing you guys did was you drew a picture. And you marked in the middle spot. And then z is 0. Where is that? Right in the middle. 0. And then z is negative 2.14. Somewhere on the left. And you're shading between them. So you guys look up for a second. See how I have this line here at 0 all the way up? Because that's the z-score I care about. That's why I don't want you to draw a line for 0 normally. Right? Normally you just put a little notch where the 0 is. I don't want people thinking that they always go to here and stop. Do you understand what I'm saying? So make your two big lines, and then, let's make this larger. And then just shade in between them. All right, so then you're going to do normal CDF. Negative 2.14, comma 0. And Selena, what'd you get? Point what?
4838.
4838. Everybody else? Good? That's this area right here. 4838, inside of here. Next one. Oh, sorry, what does it represent? It means that 0.4838, that's the area under the curve between these two z-scores. Or you could say that's the percent of the population that has a z-score between these two values. No? Or you could say that that's the percent of the population that has a z-score between those two values. Did I just say that? Or that's a probability of picking someone and having them have a z-score between those two values. All right, next one. To the right of 0.29. So draw us in, just notch where the 0 is. Where does 0.29 come in? Eduardo, where does 0.29 come in? Yes?
After the 0.
Okay, after the 0, that works. All right, and then Eduardo, what side do I shade? The left side or the right side? Right side. It says to the right. So we're going to shade to the right side. Okay? Which means that my other z-score is going to be what?
Infinity.
What was that?
Infinity.
Infinity. So right out here, infinity. Everybody on board? Put that in there. Get used to the good habits. All right, and then next, Jocelyn, what did you do for this one? You did to find your area. What'd you do? Of. 84, great. And what'd you get? I'm sorry, what'd you get?
I didn't get the answer.
Okay, get it.
0.385.
9?
Yeah.
Okay. All right, good. All right, next. Area of the center curve. And again, draw a picture. Because there's going to be a whole bunch of problems the next 2 exams if you don't have pictures with them. You're going to lose, like, I don't know, 10 points. That's a whole grade.
Whoa.
Yeah. Maybe, I don't remember, it's this exam. Definitely the next exam. I can't remember this exam. All right, so notch in the middle. And then you're going to have your 1.09. Is that on the left or the right? It's on the right somewhere. 1.83, that's also on the right. So,
About, yep.
so then one of these should be, I don't care if they're to scale, but the 109 should be to the left of the 183. Do you guys understand what I'm saying?
Yeah.
So they need to both be on the right because they're both positive. So here's my middle. They both need to be on this side. And this one should be first, that one should be second. Doesn't have to be to scale. Now you're going to draw a line straight up from them and shade between them. Please make sure that they are on the bottom. Don't put them up here. I need them on the bottom down here. It just helps keep things cleaner later because the areas will sometimes go up here if we don't have enough room for them. And then, Soraya, what'd you do next?
I did the 1.09 as the lower.
Okay, so, but you did normal CDF,
Yes,
and you did the lower was 1.09, and the upper was,
180.
so go ahead and write this down though, everybody, for me to show your work on the exam. I need you guys to write this. Normal CDF of 1.09, comma 1.83, regardless of what computer calculator you have, so that I understand that you used your calculator and that's how you found it. And then what'd you get?
1.1042.
Good. Yes, everybody good with that part? Great. Now, here is your next quiz, lab problem number 2. Find this one. Probability using a standard number distribution. Probability, that probability there. Find that probability. Is it binomial?
No.
No. What is it?
Trinomial?
Do you see the word binomial up there? No. What is it? Read it. What kind of distribution is it, guys? Normal. It says standard normal. So whenever it says standard normal, you should what? Draw a picture. Draw a picture. So you find the probability, is the area between those two z-scores.
Is there a greater thing? Zero?
Okay, so picture.
It is.
And negative 1.43, it's on this side. 0 is right in the middle. And you guys are shaded in between.
When would we shade to the left?
When it's less than.
Okay.
So that's a great question. When do you shade to the left? Well, there's only one number, it's less than that number. So you're either going to get between two numbers, or you're going to get, you guys, make sure everyone can hear. You're either going to get between two numbers, or you're going to get less than a number. And then less than a number, you're going to take that number and negative infinity. Or you're going to get greater than a number. So you're going to take that number and positive infinity. Okay, so here they give you two numbers between those two. So no infinities at all. You're just going to do just that. So here, Kat, are you done yet with this? Okay, so what'd you do for the next part?
Normal CDF,
Normal CDF.
and then I put the negative 1.43, comma 0.
And what'd you get?
0.4236.
4236. Good with everybody? Yeah.
So when we write it on the percent, what do you want us to do? Do you want us to write the percent out like anywhere specific?
You
Like
can write
line?
this, or you can write 42.36%. I don't care. Or you can leave it just like this. I don't care. Either one's fine.
Okay, cool.
Yeah, it's all good. All right. So this is one of the main points we want to make today. Adam, did I have you read already? I'd like to have you read already. No?
Not today.
Great, go ahead.
To summarize one main point,
Area?
area under the curve equals probability equals percent of population in that range. Example, area under curve between 1 standard deviation and plus 1 standard deviation equals p negative 1 greater than z greater than 1, which equals percent of population that lies between negative 1 standard deviation and positive 1 standard deviation, which are all about 68% or 0.68.
Right? So the area underneath the curve is the same thing as probability. Probability being between these two, the area under the curve between these two spots is the same as the probability of being between those two spots. It's the same thing as the percent of the population that lies between those two z-scores. They're all the same thing. Why? Because they all add to 1. Make sense? They all represent the population. Okay, so first of all, before we move on, it's really important. So the stuff we're doing today is a really big, important foundation for the next few chapters. How do you guys feel about what we've done so far with the z-scores and the drawing the curves and all that? Everybody, I need thumbs, like here, here, or here. I need thumbs from you guys. If you can show them in the beginning, or I mean, focus on you. All right, so why don't you guys, do you guys want another 30 seconds to check with your neighbors on this stuff? Because you have to have a lock on this before we move on.
Z-scores and curves and all that.
The idea of the z-score and normal CDF being between two z-scores. Okay. Everyone seems all right with that? All right. So then here's the next step. We're going to apply them. When we apply them to real life, it's not very common that someone says, hey, Johnny, what percent of the population has a z-score higher than you? Right? Do you know what I mean? Like, usually what you'll say is, hey, Johnny, what percent of the population has a height higher than you? Do you know what I'm saying? You wouldn't say, what percent of the population has a height higher than 1.3? You'd say, what percent of the population has a height higher than 67 inches or something like that? You know what I'm saying? You wouldn't throw those around. So in real life, we have actual values. So what we have to do is convert those actual values to z-scores. You all know how to do that. We've done it a bunch. What's a z-score again?
The number of standard deviations you are away from the mean.
Yeah, the number of standard deviations you are away from the mean. So you have your value. How many standard deviations is it away from the mean? How do you figure that out? Figure out how far it is from the mean and then divide by standard deviation. If it's above the mean, it better be positive. If it's below the mean, it better be negative. Otherwise, you've done something wrong. So you take your value, you subtract the mean, x minus the mean, and then divide by standard deviation. Write this down if you didn't earlier, because now we're going to use it in the next 5 minutes. I jumped the gun a little bit earlier. Okay. So here is an example. Brandon, go ahead and read.
Don't have an average of 5.2 liters of blood. Assume the variable is normally distributed and has a standard deviation of 1.3. Find the percentage of people who have less than 5.4 liters of blood in their system.
Step 1.
Convert X value to Z-scores. Step 2, draw a picture. Step 3, use normal CDF to find
The. It's supposed to be the.
PG.
Uh-huh.
Area between Z-scores.
Good. All right, so this part is exactly what you've been doing the last 15 minutes. Now you're just going to do this step first. Convert your x values to z-scores, and then you're good to go and do the same thing you've been doing. So Here, I want to know less than 5.4 liters. So I need to find the z-score for 5.4 liters. How do I do that? X minus my mean, 5.4 minus 5.2, divided by my standard deviation, 0.3. I'm going to get 0.67. Everybody okay with that part? Now I'm going to draw a picture. Now it's picture time. So, here's my mean. Here's 0.67. And what I want, I'm going to go straight up. What do I want? More than this amount or less than this amount or what? Less than that amount. So less than this. So where's the less than? On the left. Good. So now, I'm going to go all the way to the left, which means that my z-score is going to be way out here, negative infinity. So that's when you have, when you have the negative infinity or the positive infinity, is when you have the less or the more. The less, negative infinity, the more, positive infinity. All right, good. And then my last step is going to be what? What was that? Yep, great. Normal CDF of what's my lower z-score? Negative infinity, pick a large negative number. Negative 82.67. 82, comma, 0.67. That's probably where the 67 came into my mind. All right, and if I do that, I will magically get 0.7486. That means that this area here is 0.786. Everybody feeling okay with this? All you're doing is adding this step right here. Find the z-score. And then everything else is the same. Okay, you guys ready to do your lab problem? You have a lab problem. Lab problem 3.